Recording in progress.
Hello, good morning, student. Today we will discuss about the. Today you have a class of inorganic and physical chemistry, and in today class we will discuss about the bonding. In your syllabus, there is a some term. This is known as MOT, molecular orbital theory. First of all, we want to discuss what is bond. Bond. Every atom, every molecule every molecule has a bond. We can say water, ammonia, or HCl. Every molecule has a some bond. Then there is a bond means the sharing of electron. Sharing of electron that make an that complete the octet, and the bond can be divided into three category mainly. First is the covalent bond. Covalent bond means there is a formation of a bond when two atom or two atom uh, the sharing of the equal electron, we can say this is the covalent bond. In case of a water, in case of a HF, in case of a water, two hydrogen is sharing two electron with oxygen, and oxygen also sharing two electron with one H and second H. In case of HF, hydrogen and fluorine also share one electron each. Second type is that is ionic bond. Ionic bond. In case of a ionic, or there is a one is positive and second is negative, we can say cation and anion, like NaCl. Na give the electron to Cl minus, and Cl minus accept the electron from sodium ion. And third category is metallic, or we can say in case of a metallic bond. In case of every transition metal like iron, cobalt, vanadium, these type of a bond found in coordination compound, or in case metallic and coordination complex are also similar. In case of a coordination, the bond is shared by one sided, we can say coordination bond. This is the weakest bond found in coordination chemistry. Then there is a theory behind every bond. In our syllabus there is only one concept, that is the covalent bond. Covalent bond, there are different type of a theory. First theory is based upon different scientists or uh, different scientists. First is the Lewis theory. Lewis theory means first theory that explain the covalent bonding in term of a electron. In term of electron means there is some octet rule. Octet rule that can be octet rule. The electron is complete its the atom is complete its octet by sharing the electron to nearby atom. In case of a Cl2, one Cl is sharing the electron with another Cl, that forming an, in case of a chlorine there is 17 electron, and in second one 17. Each electron is sharing, that can give that can complete its octet. In case of a ammonia, in case of a ammonia there is a nitrogen and three hydrogen. In case of a nitrogen there are 7 electron, and in case of a hydrogen there are a 3 hydrogen that can sharing to give ammonia. And in case of a water there is a one two hydrogen sharing the electron with one oxygen. that complete its octet. In case of oxygen, 8 electron, 2 in one cell, and in every hydrogen sharing its electron to nearby. And in case of HF, one fluorine accept the give the electron to one hydrogen. In case of a CO2, same thing happened. But in this Lewis theory, there is some drawback. It does not tells about the double bonding, or we can say pi bonding. Also, it does not tells about the higher electronic configuration. If we take the example of a p and d orbital, it does not explain, because in case of a pf3 and pf5, in case of a pf3, the p orbital is participating in bonding with phosphorus, but in case of a pf5, the d orbital is participating with phosphorus p. That's why it does not tells about these things. Next theory is, we can say, Vesper theory. Vesper theory, or that can tells about the bond pair and lone pair. In case of a bond pair and lone pair, bond pair means bonding, and lone pair means there is a one inert orbital that can participate in bonding. In case of a methane, ammonia, and water. Three molecule. If we take three molecule, in case of a methane, there is a formation of one carbon is shared the electron with four hydrogen. But in case of ammonia, only three hydrogen is participating. And in case of a water, there are two hydrogen is participating with one oxygen, and two are the lone pair. But in case of ammonia, only one lone pair of electron. That's why the concept come from Vesper theory is the bond pair, lone pair, and there is some explanation like a shape or molecule repulsion. Repulsion means there is some repulsion between the bond pair and lone pair, and lone pair and bond pair. That's why the maximum repulsion found in lone pair repulsion, and after that lone pair bond pair repulsion, and then bond pair repulsion. The presence of that lone pair repulsion, that contract the size of the molecule, and that's why it decrease the bond angle. Bond angle means there is a decrease in there is increase in bond length. That's why the bond angle between the methane, ammonia, and water is decreased. In case of a methane, the bond angle is 109.28, but in case of a ammonia, 107.48, and in case of a water, 104.27. These are the main three examples which explained by Vesper theory. Next is next, if we compare the repulsion in case of SF6, there are a 6 bond pair. That's why its bond angle does not decrease, means the every bond is for 90 degree. But in case of a BRF F5, if we take bromine, there are it forming an octahedral type of a this one shape. In case of a 5, fluorine is participating in bonding. This way, sorry. Yes, in this case, if we take this one, SF6, in case of SF6, there are a 6 bond pair. 6 bond pair means it forming a bond angle 90 degree, regular octahedron. But in case of a BRF F5, if we take 5 bromine, that forming a bond pair, and one remaining electron, that is one lone pair, that forming a lone pair here. Sorry. This way there is a one lone pair, that's why it decrease the bond angle 84.30. In case of a XeF4, if we take, there are 4 fluorine atom that participating in bond pair, and 2 forming an lone pair, 2 forming an lone pair, one is this one is this one, that's why it forming a regular square planar type of a geometry. There are a two thing, one is shape, second is geometry. Shape means that is actual look like, but geometry, after participation in bonding, whether there is a number of lone pair, how much number of a lone pair and how much bond pair, that give the exact shape or geometry this way. In this case, I3 minus, there are a I and second one is I2. This type, there are a formation of one iodine is central metal atom and 2 are participating with in sharing with 2 bond pair, means 2 bond pair and 3 lone pair. 3 lone pair that come in this direction and this direction, that forming an shape is linear, and bond angle in this case 180 degree. And next is, what is the effect of electronegativity? If the atom, this atom, central metal atom, is participating with another metal atom, there is a some electronegativity difference between the central metal atom and the sidewise. In case of a this ammonia and NF3, in case of a NF3, hydrogen here and fluorine here, means there is a some type of a electronegativity difference. That's why if fluorine is more electronegativity as compared to hydrogen, that's why it has more repulsion and decrease its decrease its bond length. That's why bond angle is higher as compared to ammonia. This way. Next is, these are the some chart in which how much number of a bond pair and lone pair is participating. In this case, bond pair, here is lone pair. If 2 bond pair is participating and number of a lone pair in this case is 0, like a CO2. CO2, carbon, CO2. One carbon is surrounding with 2 oxygen. 2 oxygen means one, in this case forming an linear type of a structure, or we can say BeCl2. Next is, if 3 bond pair and number of lone pair is 0, in case of a BF3, the shape forming is trigonal. But if 4 bond pair are participating and number of a lone pair is 0, that forming an octa, or we can say tetrahedral, having a bond angle is 109.28. But if 5 bond pair is participating and number of lone pair is 0, in case of a PCl5, if we take phosphorus 5 and chlorine 5, 5 plus 5 by 2 means 5, total 5 means it forming a trigonal bipyramidal, having a bond, two type of a bond angle is there, one is axial, second is equatorial. In case of a axial, it forming an bond angle 90 degree, but in case of equatorial, it forming an bond angle 120 degree. If we take an example of a bond pair 6, lone pair is 0, that and forming an bond angle 90 degree. In case of a SF6, if we take sulfur half plus 6 fluorine, that give an octahedral type of a shape. But if we take bond pair 3 and lone pair 1, means one lone pair that decrease the bond angle, decrease the bond angle, which depend upon the sidewise electronegativity, if it attached with hydrogen or either it is attached with NF3 fluorine. In case of a ammonia, it decrease the bond angle, but in case of a NF3, it increase the bond angle due to more electronegativity of a fluorine atom as compared to hydrogen. But if we take case of a water, they two bond pair and two lone pair, and forming and shape is bent. And if we take an example of SF4, SF4 means there are 4 bond pair and 1 lone pair, that distort the tetrahedral shape, distort the tetrahedral shape. That's why its bond angle is also decreased. If we take an example of trigonal bipyramidal, in which 3 bond pair and 2 lone pair, that and forming and shape is T type, and the main example is ClF3. In case of a chlorine 7 electron and fluorine 3 electron, means total is 10 electron, 10 divided by 2 means 5, total 5 bond pair and 2 lone pair. But if we take an example of I3 minus, there are a 2 bond pair and 3 lone pair, that are forming and shape is linear. And in case of a square pyramid, 5 bond pair and 1 is lone pair, like in BRF5. If we take an example of square planar, there are a 4 bond pair and 2 lone pair, that and forming and shape is square planar, having an XCF4 type of a geometry. If we take some example like a BF3, in case of a BF3, 3 bond pair. 3 bond pair means that forming an square planar, or we can say trigonal. But if we add 1 fluorine means bromine get negative charge, here is negative charge. Fluorine that coordinate with another fluorine, that forming an tetrahedral structure. If we in case of a PCl5, if it is in solid state, that easily dissociated to give PCl4 plus and PCl6. This is the actual structure after dissociation with PCl5, because there are a 2 type of a bond in this case. One is axial, second is equatorial. That's why axial and equatorial, the bond distance between these are not similar. That's why in solid state it is split it into a two category. One is PCl4 plus and PCl6 minus. If we take an example of a this one trigonal bipyramidal ClF3, there are a 3 bond pair and 2 lone pair. 3 bond pair means there are a 3 fluorine that is participating in bonding, and 2 lone pair. One lone pair in this direction, one is this in this direction. That's why it forming a shape of a T type of a shape. T means that two lone pair make an symmetrical. The most stable structure which has minimum energy, we can say. That's why the lone pair repulsion is maximum. In case of this one, if we take an example of a ClF3 which has higher repulsion, if fluorine is attached with that lone pair, means lone pair bond pair. Here is bond pair lone pair, bond pair lone pair, and bond pair. But in this case it is bond pair, here is lone pair, here is lone pair repulsion is maximum in this case. That's why it is highly distable. But in this case, if we take lone pair here, lone pair here means maximum repulsion. That's why it has that's why it is unstable. But in this case, it is highly stable. The main drawback in this case, the main drawback in this case, in case of a Vesper theory, the main drawback is it does not efficiently tells about the molecule. If it has a electron deficient means it forming an stable configurations. In case of a BS3, if we take an example of a BS3, it is dimerized to give B2H6, but it does not tells about these things. It does not tells about these things. That's why it does not explain these electron deficient compound. In case of a two transition metal compound, there are a formation of some coordination bond in case of a transition metal. That's why it does not tells about the transition metal bonding. Second disadvantage of or we can say second drawback of that Vesper theory, it does not tells about the bonding in coordination complex or transition metal complex. There is a formation of some bonding. It does not tells about these things. After that, some stereochemically active, whether this is a stereochemically active or inactive. In case of a PCl5, if we take, it is easily dissociated in form of PCl4 minus and PCl6. PCl4 minus and PCl6 plus. These type of a complex. That's why it does not tells about these things. After that, it does not tells about the stereochemically active, whether it is forming an 5 bond pair or 2 lone pair, the exact bonding in higher molecule does not explain by this theory. That's why the main draw. That's why next theory will come play in the role that is the VBT, valence band theory. Valence band theory tells about the hybridization, and which type of a hybridization means mixing of an orbital, mixing an atomic orbital. In case of a ammonia, it forming an sp3. sp3 means it is an uh, 3 bond pair participating with one ammonia. This is the basic lecture. In next class, sorry, sorry, these are the content of your classes. First is your covalent bonding. Sorry, you are annotated. Yeah. This is the your content in your first unit. One is the covalent bonding. There are some theory that explain the covalent bonding. One is VBT, one is Lewis theory, second is Vesper, third one is VBT. After that, some limitation and drawback of a VBT. Then next theory come is MOT, molecular orbital theory. After that, linear combination of atomic orbital, and these are the comparison between the VBT and MOT. We will discuss these fundamental in this unit. There are in next class we will start with VBT. This is the basic class. If anyone has some doubt, please raise your hand. I will share these notes with you, also the video lecture, if you want. If anyone has any doubt, please text me. The attendance will record automatically. Yes, we will share these notes with everybody. Any doubt? After 1 month, your class will be in offline mode, and we will discuss further these unit. Because it is in online mode, there are some connectivity problem also. There is some visualization also. Yes, we will elaborate with these theory if you come in campus. It is an basic we can say it is the MOT, molecular orbital theory. The first lecture is your MOT, molecular orbital theory. Before start with MOT, we will discuss about some chemical bonding. Chemical bonding, how MOT will come. First theory come first is the bonding. Bonding means there are a participation of a two atom that form an bond to form a molecule. Molecule, there are several type of a bonding. Several type means it whether it is a covalent or some ionic, or another one is your coordination. In three category we can say. In case of a covalent, in case of a covalent, I will revise. I think this is the better way. Yeah. In this case, there are mainly three type of a theory. One is covalent bonding, that is found in every inorganic molecule like a water, ammonia, HF, or every or SF6, this type of inorganic molecule. Second theory is your ionic theory, in which every complex is formed by a cation and every anion. There is a formation of a cation anion, means there is some ionic bond. Next is coordination. Coordination complex we will study in next unit. This type of a coordination complex. Coordination means there is a formation of a coordination bond, means sharing of an electron by one sided. And in case of a covalent bonding, there are several theory that explain the covalent bonding. There are several theory that explain the covalent bonding. First theory, that is the Lewis theory, that can tell about the octet rule. Octet rule means every atom has a tendency to complete its octet. Like in case of a Cl2, one chlorine is share the electron with another chlorine, that forming an Cl2 type of a molecule. And like a ammonia, in case of a ammonia, one nitrogen is sharing the electron with three hydrogen that complete its octet. Like a ammonia, this type of a three type of a hydrogen is participating with one nitrogen. In case of a water, two hydrogen is participating with one oxygen, that complete its octet. That's why first theory that explain these type of a covalent bonding is Lewis theory. There are some limitation of a Lewis theory, means it does not explain about the shape as well as the pi bonding, as well as how much lone pair of electron in an atom. These type of a concept cannot explain by Lewis. That's why next theory come role play. That is the Vesper theory. Vesper theory. In case of a Vesper theory, there are a scientist name is Glipship in 1957, that explain how bond pair is formed, how lone pair is formed in an central metal atom, and what type of a repulsion is maximum and which type of a repulsion is minimum in this case. And next is whether it forming an pi bond, single bond, or double bond type of a concept, that can be explained by Vesper theory. But in this this theory does not explain about some uh, basic concept, like whether it is forming a dimeric form, or in this theory cannot explain about the dimer. In case of a B2H6 it forming and bonding, it does not explain by Vesper theory. Also in case of a coordination complex, or we can say transition metal complex, it does not explain by this theory. Also the stereochemically active compound like a BRF6 minus, not explain by this theory. Also, there is a problem between these higher compound. It does not explain why it forming a distorted octahedral type of a symmetry or another type of a symmetry. That's why next theory come is VBT. In next class, we will discuss about VBT. After that, MOT, molecular orbital theory, and then we will continue MOT further. If any doubt, please let me know. Where we will get the notes or record. I will mail you. I will mail you the notes as well as recorded video. Every student write your name before joining in that meeting. Your attendance will automatically record based on your name. That's why you join with your name. Any doubt? Don't write the name in chat box, please. I am saying that if you are joining with your name, I will tell about the book name. These are the basic concept of a bonding. If any doubt, ClF3. In case of a ClF3, there is a chlorine is central metal atom and fluorine is sidewise or surrounding atom. In in this case, I will explain. I will explain and text you. Yes, how electronegativity atom decrease the repulsion in molecule, because electronegativity atom has a tendency to repel the electron because it has a high, because it has a high electron density. That's why it has a tendency for a repulsion. And another, yes, it will link starting of a class. Okay, I will share these notes. Any doubt? Okay, then we will continue next class. Yes, it is the first class of EE. Yes. Yes, class of MNC. Okay, student. You
Recording stopped.